Welcome to physics class. Today we will study about the combination or grouping of resistors. In electrical gadgets, we need to connect two or more resistors. Various resistors may be connected with one another to form a network. The resistor may be connected in the following two types: in series, in parallel. First of all, we will discuss series combination of resistors. Series combination: two or more resistors are said to be connected in series if they are connected end to end consecutively in an electric circuit. When the resistors in a circuit are connected in series, the current I passing through each resistor is the same. Each resistor has a different potential difference across its ends, but the sum of the potential differences across all the resistances is equal to the voltage of the battery. It is clear from the diagram there are three resistors R1, R2, R3. Potential difference across them V1, V2, V3 and I current is flowing through circuit. Draw this circuit in your notebook. Let us calculate equivalent resistance of three resistors connected in series. Consider three resistors of resistances R1, R2 and R3. Current flowing through each resistor I current. Potential difference across resistors R1, R2 and R3 are V1, V2 and V3 respectively. What does it mean? Potential difference across R1 is V1, across resistor R2 is V2 and across resistor R3 is V3. Now, total potential difference in the series circuit can be represented by V, which can be calculated by adding V1 plus V2 plus V3. By Ohm's law, V1 can be calculated as V equal to IR, but here 1 is used for the first resistor. Then it can be written as I. Current is same but resistance or resistor is different, that is R1. V2 IR2 and V3, that is IR3. This is equation 1. Now equation 1 becomes V equal to IR1 IR2 plus IR3. From this equation we have used a value of V1, V2 and V3 here. I is common, so it will become R1 plus R2 plus R3. If Rs be the effective or equivalent resistance of the series combination, then V is equal to IRS. This is equation second. V equal to I R1 plus R2 plus R3. Now from Ohm's law it will be third equation. From equation 2 and 3 we will fill the value of V. Equation 2 becomes IRS equal to I common R1 plus R2 plus R3. It will cancel out and it will become RS equal to R1 plus R2 plus R3. When a number of resistors are connected in series, the total resistance is equal to the sum of equivalent resistance. Thus, total resistance of the series circuit is more than the maximum resistance in the circuit. However, the main disadvantage of a series circuit is that if one device resistor fails, the current in the whole circuit ceases to flow. Parallel combination of resistors. Two or more resistors are said to be connected in parallel if one end of a resistor is connected to one end of other resistor and the second end of first resistor is connected to second end of the other resistor such that the potential difference across each resistor is the same. When the resistors in a circuit are connected in parallel, all the resistors have the same potential across them. Different amount of current flows through each resistor, but the sum of current flowing through all the resistances is equal to the total current flowing in the circuit. Consider there are three resistors R1, R2 and R3 respectively connected in the parallel. Let V be the potential difference across each resistor. Current I drawn from the cell divide into three parts, that is I1, I2 and I3 at junction point A. Let currents I1, I2 and I3 flow through the resistors R1, R2 and R3 respectively. You have to draw this circuit in your notebook. Now let us calculate equivalent resistance in the parallel combination. Resistors are connected in parallel. Consider three resistors R1, R2 and R3. Potential difference across each resistor V. Current flowing through three resistors I1, I2 and I3 respectively. I1 is current passing through R1, I2 is the current passing through R2 resistor and I3 current passing through third resistor, that is R3. Now let us calculate total current to the circuit. I is equal to I1 plus I2 plus I3. Here current drawn I from the cell divides into the three parts I1, I2 and I3 flows through the resistor R1, R2 and R3. From Ohm's law, current in R1 is I1, which is in turn equal to V upon R1. Now current in R2 resistance is I2, its value is V upon R2. Third one, current in resistor R3, which is I3, V upon R3. Let us fill the values in equation 1. It will become 1 is I equal to I1 plus I2 plus I3. It will become V upon RP, means resistors are connected in parallel combination. According to Ohm's law, V is equal to IR, I equal to V upon R. Fill the value of I1, that is V upon R1. I2, that is V upon R2. I3, that is V upon R3. V upon Rp, it can be written as V is common 1 upon R1 plus 1 upon R2 plus 1 upon R3. It will cancel out and 1 upon Rp 1 upon R1, 1 upon R2 plus 1 upon R3. Hence, when a number of resistors are connected in parallel, the reciprocal of the equivalent resistance is equal to the sum of reciprocals of the individual resistances. Total resistance of a circuit is always less than the smallest resistance in the circuit. In homes, electrical devices are connected in parallel, not in series. Any electrical device can be turned on or off without affecting the functioning of other devices. Thanks for watching.